Today we're going to be talking about antennas. We're going to cover a lot of the basics, the different types of antennas, how to read an antenna pattern plot, and especially how to visualize antenna coverage in 3 dimensions. So we're going to be talking about 5 different types of antennas today, starting with the basic stick omnidirectional antenna, moving to another type of omnidirectional antenna called a squint or a down tilt antenna, which is pretty interesting. And then we have 3 different types of panel or sector, or sometimes indoors they're called patch antennas, that are used for different applications outdoors. And now we'll move on to panel or directional antennas. So these are all different types of panels. This model is a 60-degree by 60-degree pattern, and in this case we're including the mounting hardware, so you can see you can mount this to a building, you can clamp it to a pole, what have you, but this is going to provide a nice, even, and also symmetric coverage pattern in both the H and the E planes. This is an antenna that we use a lot on outdoor mesh backhauls. This is the 5614. This has a 60-degree H plane and a much narrower E plane, and the reason for that is that it's a high gain antenna. It's about 14 dBi of gain. So this antenna is about 14 degrees in the vertical plane and as I said, about 60 in the horizontal. And finally, this is another high gain directional. This also has a symmetric pattern, so this is going to be a 30-degree H plane by 30-degree E plane, and it's got 14 dBi of gain. So you might have noticed that the difference, both antennas have 14 dBi of gain, but this one has a very wide H plane and a narrow E plane, and this one has a symmetric pattern. So this has to basically is a choice that the antenna designer makes to produce an antenna for a specific purpose. The symmetric pattern is going to do very well if you're for point-to-point backhaul shots where you don't need to cover a wide field, and if I'm doing a mesh deployment where I might want to cover multiple mesh points that are spread horizontally across the space from the vantage point of the antenna, I might need a little wider pattern, but I still want the high gain. And of course, I have to be mindful that I've given up some of my vertical coverage to get that horizontal range.